Hello everyone. Now I'm going to take the basic concepts of database management system. Now I will start with the definition of what is DBMS. Okay. So database. What is database? So everyone knows what is database actually. It's a collection of data. So when I come to the part database management system, it's a collection of interrelated data and set of programs to access those data. So this is a basic definition of database management system. It's a collection of interrelated data and set of programs to access those data. Okay, set of interrelated data in the sense the data should have some relationship between this. Okay, so if data don't have any relationship, then we cannot we cannot retrieve the data exactly. So that's why we have to insert the data having some relationship between them. Okay, so that's why we term called interrelated data and set of programs. So we have some softwares, right? For extracting the data. So that programs are called the set of programs. Okay, so this is the basic definition of DBMS. Okay. So, what is the exact objective of database management system? Why we go for database management system? Everyone we call it as database is a collection of intelligence, a collection of data like that, but it's not an exact objective. So, it's a the database management system. Okay, it is used to store, manipulate and retrieve effectively and efficiently. That is a major objective of database management system. Okay, so we need to store, right? So exactly that is a basic things for database actually. So but it's not an exact objective. So we need to store and also manipulate and retrieve the data efficiently and what kind of data we want. Okay, so this is a major objective of database management system. Okay. Fine. Now we're going to discuss about some traditional approach things. So before using database management system, we use some sort of techniques, right? So that is called traditional database approach. In this traditional database approach, we face some kind of disadvantages. Okay, that's why we go for this kind of database management system concepts and all. Okay, so in this database management, what kind of disadvantages we face in our traditional approach that we are going to discuss in detail. Okay, so in disadvantages of traditional approach. Okay. So the first one, data redundancy. Data redundancy and inconsistency. Data redundancy and inconsistency. Difficult in accessing the data. Difficult in accessing data. Data integrity. Data integrity. Data isolation. Atomicity. Atomicity problem. Atomicity, you can say in English. Atomicity. Concurrent access anomalies. Concurrent access anomalies. Then finally, it's a security issues. These are the major disadvantages actually we face when we used this kind of traditional approach methods. Okay, so what is meant by data redundancy and inconsistency? Data redundancy in the sense duplication. The exact meaning of this redundancy is nothing but duplication. Okay, so when I store the data, okay, so that particular data which is available in multiple places. Okay, so that is called data redundancy. In my traditional approach, or independent files, it's like an OS files. Okay, so I'm going to store some kind of data in one places. It's mandatory, or some needed tables. I need to store the same data again. Okay, so in this kind of situation, so it's not a problem for duplicating value in somewhere, but where we going to get the problem? Na? So I'm going to retrieve some data, or I'm going to manipulate, or I'm going to edit. Okay, so some instance have same value. Okay, for example, if I'm going to change phone number. Okay, so let us assume the person have only one phone number. Okay, so one table have I just inserted one phone number in particular for one person. Okay, so that person information is available in multiple places. Okay, so there also I need to mention that phone number. Okay, now I'm going to change the phone number of the particular phone number of the person. So if that person phone number which is available in multiple places, if I forget to store, or if I forget to update any one of the places, then my data leads inconsistency. Okay, that means same person have multiple values. Same person have multiple values. If I'm going to retrieve the phone number of the particular person, I may get different kind of values. Okay, which leads database inconsistency. Okay, that is a major problem I need to face in my traditional approach. Okay, this is called data redundancy and inconsistency. Okay, so that is first disadvantage. The next one, difficult in accessing data. So what this mean by difficult in accessing data? Because we have a data. So what is difficult in that? Is obviously we have some sort of difficulty I am facing for accessing the data. What kind of difficulty in this is? So if, all the data, right? So if I'm going to store some kind of information in my table, okay, in my traditional approach, okay. So some person raises a query, okay. I retrieve some values, okay. So again. The query will some person asking some sort of some another sort of queries. Okay, so what I need to do again, I need to write a query, or again I need to write some software for retrieving the data. Okay, so every questions arise from that customer side. Okay, I need to write different kind of program for getting the information. This is a very tedious process, you know. So I need to restrict in that. Okay, so I need to remove this kind of difficulties from my databases. Whatever query raised, okay, I have some solution for giving the proper answer. Okay, so that also I need to include. So, but that kind of facility is not available in my traditional approach. Okay, that is second disadvantages. The next one, data integrity. So for adding constraints, removing constraints, adding some kind of rules and regulation in that particular table or particular database, it's highly difficult in traditional approach. Okay, so that is data integrity. Then data isolation. So different format, because in the these are, I already told, these are independent files, right? Or some team creating a file in some format, another team creating a file in some other format. Okay, so if I want to integrate all those things, that I face some consequences. Okay, so different files are different in different format. They are not in the common format. So in this case, I cannot get an exact value. Okay, in this particular format. Okay, I need to change again and again. I need to change the format again. So this is also some. It leads to some tedious process for getting exact information or giving exact information to the customer. Okay, so this is called data isolation. So there is another disadvantage. Next one, atomicity problem. This is very important problem I'm facing in my traditional approach. And definitely I need to remove from that. Okay, so that's why we go for this kind of database management system or DBMS concept actually. Okay, fine. What is meant by atomicity? Atomicity in the sense, fine. For example, so I'm going to book some. I'm going to transfer some information. Let's say example. I'm going to transfer some amount from A to B. Okay, account A to account B. Okay, so once I start a transaction, I just transfer some amount, like for example 100 rupees. Okay, if the account A have 200, from 200 100 rupees to account B. Okay, so before adding the particular amount to B, okay, during the transaction, between the transaction, system got crash. Okay, so the amount got removed. Okay, 100 rupees from account A. Okay, but it's not credited to account B. That means either like amount removed from account A, and that is not credited, that is not added to account B. Meanwhile, the system got crashed. What will happen? So nothing. So again, in my traditional approach, what I need to do, I need to check the account A and account B, whether it's credited or debited from both the account. So again, I going to transfer from B to A. So this is also again, it's a tedious process. What exactly should happen to this particular situation? The amount, it's automatically come back to this original position, right? But that is not possible in this traditional approach. Okay, so this kind of problem, right? This is a problem happen in the situation like banking, in prices, and some ticket booking. So many places which leads this kind of difficulties actually. So we need to overcome these difficulties or these disadvantages also. Okay, so this kind of problem, either that means both operation will occur, either credit as well as debit, or neither occur. This is called atomicity. Either both operation will occur, credit as well as debit, or neither occur. This is called atomicity problem. Okay. The next one, concurrent access anomalies. What is meant by concurrent access? It's very basic problem and very important problem also. Everyone in this current scenario, because everyone using online things, online booking, online transactions, everything, right? So we have to control that control the kind of disadvantages in this scenario. So I will tell you what is meant by concurrent access. Concurrent access means a particular data. Okay, the different person using the same data simultaneously. So the data A, okay, both person X and Y are going to access a particular point of time. Okay, so in this situation, I need to control the concurrent access. Okay, because both the person are going to hit, some updation problem will occur, right? So here I need to provide some kind of protocols, some kind of constraints in this particular scenario. I need to put log on this particular data. So okay, what is meant by log? So this one comes in next videos, and how I supposed to control this kind of concurrent access, the data which is accessed by multiple users simultaneously. The particular data going to access particular user will access the particular data simultaneously. Okay, more than one user. For example, X and Y. Okay, different person. Okay, going to access the data A simultaneously. What will happen? The updation problem will occur, right? So on the updation problem, how I supposed to control that? I need to provide some kind of protocols for some kind of rules or constraints, whatever, some ideas I need to implement in this particular scenario. Okay, so this is called concurrent access anomalies. Definitely, I need to control this kind of concurrent access anomalies. How am I supposed to control that? And we'll discuss in upcoming videos. Okay, it's very interesting topic. I will tell you the name of the concept is nothing but logging protocols. We have many logging protocols: read and write log protocol, log-based protocol, time-based protocol. Okay, so these kind of logging protocols, which is exactly used to control this concurrent access anomalies. Okay, fine. Next, security issues. Obviously, these security issues are very general issues, right? In any kind of concepts, any technology we introduce, but we cannot restrict fully in terms of security, obviously, right? So here also we're going to face some security issues. I'll tell you an example. In this traditional approach, what kind of security issues will come actually? Okay, so that means I have an I have a bank. I'm running on bank. So in this bank, I have multiple accountants details. Okay, if anyone wants to know the account details of that particular person or that person things. Okay, so what I supposed to do? I need to give the information to the person, but I cannot restrict. Okay, so I cannot give the information of the particular person alone. The person can see another account details also. Okay, so we don't have any separate view for that particular person those who are requesting. Okay, so that one I need to control, right? Because some other person cannot not have a rights to see my personal details. Okay, so that I need to give some restriction over there. So this is one of the security issues I face in this traditional approach. In DBMS concept, we introduce. Okay, I'll tell you one solution also. Okay, we introduce views concept. In this view, I can give. I can give some portions alone. Some portion. I have an entire table. Out of that entire table, I can give some portion only in this view format. Okay, so that I can do in this in RDBMS concept, but that is not applicable in traditional approach. Okay, so these are the major issues I have faced in my traditional approach. Okay, data redundancy and inconsistency, duplication, difficulty in accessing your data. Okay, then the data integrity, data isolation, atomicity problem. So either debit or credit occur or neither occur. Okay, so that is one of the important problem I face. So definitely we need to um, omit that. Okay, then concurrent access, so multiple user accessing same data simultaneously. Okay, that also I need to restrict. The finally security issues. These are the major problem I have faced. Okay, how am I supposed to overcome this problem in my traditional in my advanced technique called RDBMS and all that? We're going to discuss in upcoming videos. Okay. Fine. So now I'll tell you one small definition: DBMS and RDBMS. Okay. So small, it's kind of equation only. Okay. So DBMS in the sense it's an organization collection of data. I told data. It is a general term. It's a generalized term actually. DBMS. What is meant by RDBMS? Referential integrity plus DBMS. Okay, so this DBMS we discussed what is meant by DBMS. Okay, calcium mineral data, whatever. Okay, RDBMS in the sense it's a referential integrity plus DBMS. It's an exact definition for RDBMS. What is meant by referential integrity in the sense? It's nothing but I'll tell you the term and all right now, but the explanation I'll give you later. Okay, referential integrity. It's a very common word only. Foreign key. Foreign key plus DBMS. This is a simple and exact definition for RDBMS. Okay, this is RDBMS only we are using nowadays. Okay, fine. Okay, now we're going to discuss some basic definition. Okay, instance. This is our definition only. Instance and schema. So instance, what is meant by instance? Because these are the terms we using inside our upcoming concepts. Okay, so we should know what is instance and what is schema and what is meant by instance. Instance is nothing but it's an particular moment, a particular moment. Particular moment, what kind of data available. What kind of data? A particular moment, what kind of, or what type of, or what data available in this available is in database. Available in database, that is called instance. I'm going to search some value, or I'm going to retrieve some value, or I'm going to delete, or going to update some value. Okay, I'm going to see my data inside the database, right? At that particular moment, what type of value, or what kind of value, or what value I have in my database. Okay, that is called instance of the database. Instance of the database. Okay, schema is nothing but some overall design structure. Overall design structure. The complete database design part. Its design part is called schema. Okay, so you should know what is instance, what is schema. Okay, fine. Next, we're going to discuss data models. Okay, it's very important and easy also. You are very well know what is maybe model. You know what is maybe model? Model what is the design, right? So if I'm going to create one project, okay. So what kind of project? So it's not like either software or whatever. Okay, first I need to give the problem statement. Okay, so these are the hierarchical order, right? First I need to give the problem statement. From problem statement to design, design to coding, coding to testing and implementation. This is an SDLC part, right? So here in DBMS also we following this kind of approach only. Okay, first I need to collect the problem statement from the customer side. Okay, from the problem statement I'm gonna make a design. Okay, design is a very easy part of understanding, right? It's a graphical representation of the particular problem. Okay, we can easily understand the concept also with the use of this diagram, some symbolic representations. Okay, that also available in DBMS. Okay, so we have many data models. Okay, in this among those models, we're going to see in detail about entity relationship model alone. Others are it's very simple, but in our syllabus we're going to discuss about what is ER diagram in detail. But I will tell you what are the data model available in DBMS. Okay, first one, as I told, ER model. Okay, what is meant by ER model in the sense entity relationship model. Entity relationship model. Entity relationship. I'll tell you what is entity relationship model. Next, relational model. Relational model. Relational model. Next, object oriented data model. Object oriented data model. Next, network data model. Network model. Next, hierarchical model. Then finally, semi-structured data model. Semi-structured data model. Hierarchical model, semi-structured data model. These are the various data model we have for designing our DBMS concepts. Okay, DBMS, that means DBMS concept in the sense that we're going to design database, right? For before creating the logical database, what we have to create this kind of designs. Okay, we have to choose any one of the design based on our problem statement. Okay, from the problem from the design part to convert into logical database. That all we'll discuss in detail about upcoming things. Okay, so entity relationship model. So entity relationship model is, we have three main component: entity, attribute, and relationship. Okay, then we'll discuss in detail later. Then relational model. Relational model is something, but it's contain rows and columns, and we have unique column names. Okay, so using those relationships and we can easily retrieve the data. This is another it's a rows and columns part. Okay, normal table structure. Okay, then object oriented data model. This is also like our relational model only, but here we want to introduce some object oriented concepts. You are very well know, right, what is object oriented notions and all. So encapsulation, inheritance, and classes, objects, everything we gonna include in our database model. Okay, so this is an advanced one. Actually, we have a separate topic how I supposed to create object oriented data model. So that we'll discuss in our next video. Okay, I'll give you some small examples for how to create this data model. Next, network data model and hierarchical model. These are all very simplest model, so we don't need to see it's a one-to-one map, one-to-many mapping, and many-to-many mapping. So this comes under network model and hierarchical model. It's a very simple approach. Then finally, the semi-structured data model. What is my semi-structured data model? This semi-structured data model, so we using for creating a database. So using XML part, okay, XML language you're using for creating semi-structured data model. This also is very a welcome one, because nowadays we are using XML databases in many scenarios actually. So this XML database is a schema less. It's also called schema less schema less. Okay, because we don't have any general structure for that. Okay, so you are from the from the problem statement, we're going to create a design using XML language. Okay, so we have some XML rules and regulations. We have a particular grammatical part. Using that one, we're going to create XML design. So we don't have any standard structure. Okay, we use a user friendly part. So however you want to create a database, you can create on skeleton. Okay, create on skeleton. So used on that, that is also called grammar. It seems. Okay, so using those grammar, I'm going to create a databases. Okay, so this is a semi-structured data model. In many scenarios, we using this kind of semi-structured database model. Okay, so these are the small introduction about what is data model. Data model is nothing but a graphical structure for easy understanding of your problem. Okay, so every model have some specific symbolic representation. Using the representations, we can easily understand the problem statements also. Okay, so now we going to discuss about what is entity relationship model. So it's a very easy approach actually. Entity relationship data model. Okay, so definitely we need to understand what is entity relationship model, because this kind of approach are using many industries. Okay, and so this is top down approach. This is top down approach, and one more concept also is that it's called bottom up approach. That is nothing but normalization. That also very interesting topic actually for designing your database. That is bottom up approach. Bottom up approach. So that normalization, we have a separate video that we can discuss in detail about. Now we will discuss this in detail. Just top down approach, because first problem statement, from problem statement to ER diagram. So ER diagram, we have some hierarchical order. So from the ER diagram to, we're going to convert into databases. So it's called top-down approach. So in this entity relationship model, it's a basic definition again the same. It's a graphical representation for understanding your easy way of understanding your problem. Okay, fine. So in this entity relationship model, we have three components we need to explain. Okay, first one, in this name itself, we have entity. Next, attribute, then relationship. Fine. Okay, so these are the major component we're going to discuss in this entity relationship model. So what is meant by entity? Okay, so entity, first I will discuss the definition of each thing. Next we'll move into deep about what is that particular topic, what is entity, what is attribute, and we have different types and different notations and all. Okay, so entity, all real world objects are called entity. Simply called all nouns are called entity. For example, employee, student, right, instructor. So these are all comes under entity, but all real world object or real time things are called entity. What is meant by attribute? It's very easy definition. It's the characteristics of an entity. Even more simple, it's nothing but properties of an entity. Properties of an entity. For example, I have the entity called student. Okay, student is an entity. So what are the properties? What are the characteristics of an entity? Student, student ID, student name, register number, roll number, address, phone number, and keep on however you want. You can include those things. Okay, that is nothing but attribute, characteristics of an entity. What is meant by relationship? What is my relationship? The name itself you can easily understand. Relationship is nothing but association between entities. Okay, so I can connect any number of entities. Okay, what kind of relationship between these two that we need to mention? That is nothing but relationship. So we have many topics, many concepts we're gonna see under that relationship. Okay, I will tell you later. Okay, so entity. So I'll show a small representation. Entity we're going to represent in this rectangle box. This is called entity, and this is a common representation. And the types have different things. Okay, then this is called attribute, and this is the representation of relationship. Okay, so this is a common notation, and under this type, okay, entity have some type of some types actually. Then attributes also have some types, and relationship also some concepts in that. So every types have some unique annotations. Okay, that I will explain you now. Fine. Now, first we'll discuss what is entity and its types. Okay, first we'll finish off that. Entity, it's a real world objects I told. Entity, two types. One is in strong entity. Another one, weak entity. Strong entity. Another one, weak entity. What is the strong entity? Strong entity in this, every entity have its own key attribute. Every entity have its own key attribute. Key attribute in the sense, okay, I will tell you what is the key attribute under a little bit later. Okay, so every entity have its own key attribute. Key attribute. Weak entity in the sense does not have own key attribute. Own key attribute. Then it's called weak entity. Key attribute in the sense every entity have some unique valued attribute. For example, if I have the entity called student have the attribute called register number, phone number, something like that. So among those, which attribute have unique values? Then it's called key attribute. Every value, okay, the particular attribute is going to insert, right? That should be an unique. Okay, so that is called prime or key attribute or prime attribute. Also, you can say, okay, that is called key attribute. If the entity have its own key attribute, then it is called strong entity. Okay, if the entity does not have its own key attribute, it depends on some other attribute. It depends on some other entity. So if it depends on some other entity, then it is called weak entity. Strong entity as such the same notation. Strong entity have the same notation. If it is weak entity, you have to represent like this. It's a double line rectangle. Okay, so if you mention double line rectangle, then it's a representation of weak entity. Okay, so does have its own key attribute, does not have its own key attribute, then it's called strong and weak entity. Okay, next, these are the types of an entity. Next, we're going to see attribute. It's very important. Attribute. So attribute. Simple. Simple and composite attribute. Stored and derived attribute. Then multi-value attribute. Okay, simple attribute. Every attribute have like a single value. Okay, simple, or you can say single also, single value. Composite in the sense you can split that. Okay, you can divide. For example, if it is a phone Address again I can divide, right? For how can I divide door number, street name, like something like that. That's called composite attribute. Okay, we can divide further. Then stored attribute. Stored attribute, that means it's a permanently you can store. For example, a name. It's a permanent one, right? So we cannot change keep on. That's called stored attribute. What is meant by derived attribute? Derived attribute it's a plays a major role, because if I have a derived attribute, I need to do some changes in my logical database design. Okay, so stored attribute is a permanent one. Derived attribute it's depend on some other attribute. For example, date of birth, right? Date of birth and age. Okay, in these things, age which depend on what? Your date of birth, right? So age which is derived from your date of birth. So like that, year of experience, the year of experience which is depend on date of join. So like that. So age is a derived data, right? Age which is depend on your date of birth. If I know the date of birth, then only you can find out the ages. That is called derived attribute. Okay. So this simple and composite, these are all common notation only. If I have a derived attribute, that should be represent this dotted oval shape. Dotted oval shape. This is called derived attribute. Then multi-value attribute. What is multi-value attribute? One person have more than one value. One person, for example, if I say an example, you can easily understand. Skill set. Skill set. So, one particular person have more than one skill set. The person may know Java, may know C#, may know Python, something like that, right? So, one particular person, a particular instance have more than one value, then it is called multi-value attribute. One of the finest example is skill set. So, how are we supposed to represent the skill set? It's a double line oval shape. So, this is called multi-value attribute. So, these are the some types of attributes. Okay, simple or single composite, stored and derived attribute, multi-value attributes. Okay, and the corresponding representation I have mentioned here. Okay, fine. So in this attribute, I need to say one more thing: domain. Domain of an attribute. Domain. It's not a domain. Domain of an attribute. What is meant by domain attribute? It's a set of permittable or possible values. Domain possible values I can store in this particular attribute. Okay, so that is called domain of an attribute. Okay, set of permittable or possible values. If I say an example, you can easily understand. For example, gender. Okay, in gender, you can say either male or female or transgender. Out of this three, you cannot give any other value, right? This is called domain of an attribute. This is called domain of an attribute. If it is in marital status, right? Either married or unmarried or widow, right? These are the set of parameters like that month and week, days, like that. So these all have some constant value. Out of the value, you cannot give any own defined values and all. Okay, so this is called domain of an attribute. Okay, you're supposed to know this definition also. Hope you understand this. Fine. So this is called. These are all different things of entity relationship model. Okay, so what is entity? What is attribute? Then next we're going to discuss about what is relationship. That's very important part. Relationship. I already told you relationship is nothing but it's an association between the entities, right? Association between the entities. So in this relationship, we need to divide into three different parts. That types are called degree of relationship. Degree of what is degree of relationship? What is degree of relationship? How many entities participating in this particular relationship? Then it based on that we can divide. Okay, so that is called degree of relationship. How many entities participating? If only one entity participating, then it is called unary. If two entity participating, then it is called binary. three entities participating, then it is called ternary. Okay, so this is called degree of a relationship: unary, binary, ternary. Okay, so only one entity in a unary, two entity means binary, three entity means ternary. Okay, so this is called degree of relationship. In this degree, we need to know one more concept additionally called cardinality. Okay, so I am going to associate with this cardinality. Cardinality. What is my cardinality? Cardinality in the sense, the instance, right? The instance is particular value, what type of value I have in my database when I'm going to see, right? That's called instance of a database, right? That instance of a database, that instance, one instance of an entity, how going to relate with another instance of another entity, one single instance of an entity. Okay, how we going to connect or how we going to relate with the instance of another entity, that is called cardinality of a relationship. Okay, so this cardinality again I'm going to divide into going into four types actually. Okay, one, this is not things. Okay, I tell you, one to one, one to many, many to one, many to many. This is called cardinal. I told you, right, it's a four type, but one type it's like simply opposite with previous one. So this not comes under this type, but we need to know. Okay, this is also one of the type of this cardinality. Okay, one to one cardinality, one to many cardinality, many to one cardinality, many to many cardinality. So I'll tell you the definition for what is one to one. This is one to one mapping actually. It's a mapping cardinality. Also you can say, so one to one means single instance of an entity which is related with a single instance of another entity, then it is called one to one. For example, if I have a person and chair, person is one entity, chair is another entity. Single instance of a person, this person entity will mapping with a single instance of an entity called chair. Okay, then it's called one to one mapping. Okay, this is called one-to-one mapping. Definitely, it's a graphical representation. Okay, one-to-one cardinality. Single instance of an entity called person, single instance of an entity called char, which is connected with one-to-one basis. Okay, this is called one-to-one cardinality. Is a one-to-many cardinality in the sense a single instance of an entity which related or which connected with more than one instance of another entity. More than one instance of another entity. For example, organization, employee. Single organization may have more than one employee, like that. So single instance of an entity called organization which related with or which connected with or mapped with more than one instance of an entity called employee. Okay, this is called one to many. One to many. Then many to one in the sense is the reverse process. Reverse process. Okay. Employee. Okay, this is employee and this is department. Okay, employee and department. Okay, one department may have more than one employee which belongs to single department, more than one employee which belongs to another department, like that. So this is called many to one. It's a reverse process of one to many. Okay, so the rules also have same. So what is rule? I'll tell you. So now I said the rules, right? But the meaning is how I supposed to assign the keys and all. Okay, key and all I will tell you later. Okay, one to many, because when I go for the logical database design part, right? We're going to convert this design to logical database design. That time we need to know what is the importance of this kind of mapping and all. Okay, so M2 this is multiple instances which connected with a single instance. Many to many cardinality in the sense it's a combination of one to one and many to many, like that, many to one, like that. Okay, so more than one instance of an entity which associated with or connected with more than one instance of another entity. Okay, for example, student course. One student can enroll any number of courses. The same course can enroll by another student also, right? So you can connect it in reverse process also. So one student can enroll any number of courses, like that. Any number of courses can enroll by single student also. Okay, so this is called many to many cardinality. Okay, so cardinality is nothing but so how the instance which related with the entities. Okay, if it is one way related means one to one, more than one related means one to many or many to one, more than instance are connected with each other, then it's called many to many. Okay, this is definition and explanation about what is cardinality. Okay, fine. So this is these two, right? Unary and cardinality. We need to combine these two for making some creations of tables and all. Okay. Now we're going to discuss about how we're going to draw the ER diagram, right? So we have an ER diagram. So this is these are the major things we have discussed. What is entity relationship model? So we need to combine the entire thing. Right? So this is entity, this is attribute, and this is the relationship, and we have to make some connections in the right. So I will give you a small example also. Okay, for one college database, I'm going to create college DB. Okay, so college contain many departments. Okay, so fine. Next, these are the problem statement, because first I need to consolidate the problem statement. That's very important, because from customer side they give the requirement in their own basis, right? But that and all, it's not suitable for our rules, right? So we have some sort of team. We're going to segregate, and we need to formulate. We need to organize that problem statement. Okay, given by the customer in our favorite part, okay, in our user friendly part, then only we can create complete database design. Okay, so college, so that only I'm going to do here. Okay, so college contain many department. So then one department have more employees. More employees are instructors. Then we can say instructor. That's a suitable word. Instructor. One instructor belongs to one department. Okay. Then one instructor is taught any number of subjects, courses. Any number of courses. One instructor can taught any number of courses. Then student. One student can enroll any number of courses. Then one course can enroll by any number of students. So this is a simple problem, and I'm going to include one more concept. I will tell you later what is participation actually. One instructor headed by one department. Okay, this is simple problem statement I have mentioned here. So from the problem statement, I'm going to convert into ER diagram. Okay, so one department have more than one instructor. So this is and then one instructor belongs to one department. One instructor can start any number of courses. One student can enroll any number of courses. One course enroll any number of students. And finally, it's like one header of single department. Okay, so this is problem statement. From the problem statement, we're going to convert into ER diagram, right? But before converting, we have to follow some rules, not rules, some steps. What is the first step? Step 1. First, we need to identify entity. Identify entities. Step 2. Need to identify attributes. Step 3. Identify key attributes. Then identify relationships. So these are some of the basic steps we need to follow for making this conversion from problem statement to ER diagram. So step 1. So I already told you it's easy way of finding the entities in the earth. Okay, all nouns, all real objects are called entity, right? So from the problem statement we can find out what are all nouns. Okay, this all comes comes under entity type. Okay, so we just see this, right? This is I hope understand these steps. Okay, so I'm going to erase it. I'm going to follow those steps and draw the complete ER diagram. Okay, so I will draw ER diagram directly. Okay, it's very easy part. Fine. So from problem statement, college contain many databases. So here college also one of the noun, but we cannot take it as an entity over here because I'm going to create a database for college only. So I'm going to omit that entity called college. Okay. So department. It's one department. Then another one instructor. Then is another student. Then course. So out of which any other nouns are there? No, right? So fine. These are the 4 entities I have mentioned here. The next one we need to find out the attributes. So for simplicity, I just make it two attributes only. Department ID, department name. Instructor ID, instructor name, like that. Student ID, student name, yes, name. Then course ID, so whole shape. Okay, course name. Okay, so these are the attributes I have found out. What is my next step? I need to find out the key attribute. Key attribute. What is the key attribute? I told you already. Key attribute is a unique value you can enforce in this particular attribute. Then it's called key attribute. What are the you have to find out which attribute is suitable for enforcing or inserting unique values. You're going to accept only unique values. Then it is suitable for that particular attribute. Now, for example, in this department table, department ID. Definitely that should be unique, right? So you have to underline that. If it is a key attribute, you need to underline that. Okay, if I like that instructor ID, course ID, and student ID. These are all the prime attribute or key attribute. Okay, so what is my next step? We need to find out the relationship between the tables from the problem statement. So one department have more instructor, one or more instructor. Okay, like that one instructor belongs to only one department. If I'm going to combine these two, one department have more than one employee, one to many cardinality. So department and instructor, right? So one department have, you can give any name, any suitable name for relationship. Okay, one department have more than one employee. Okay, so in this case, the one department have more than one to many cardinality. One to one, you may it one to one also. First one department have more than one to one. One to one instructor belongs to one department. One to one. So you just combine these two, one to many, which cardinality is more higher, that one you can name it. Okay, so the cardinality you have to mention like this in this line. No, so above that line you have to mention the cardinality. Then is there any one instructor can taught any number of courses. One instructor can taught any number of one to many taught. Instructor can taught any number of courses. It depend upon the problem statement. That ER diagram getting very simple. Okay, because my college have this kind of rules. So for that, I am going to draw this ER diagram. I am going to create the database for this design. Okay, this diagram and this database is not suitable for some other college because the rules and regulations may get different. Okay, so based on the problem statement, again based on the problem statement, I am going to draw this ER diagram. I am going to create my own databases. Okay, the instructor can start any number of courses, and one student can enroll any number of courses. One course, this dimension. One course can enroll. Okay, one course can enroll by any number of one student can enroll any number of courses like that. What is the next statement? One course can enroll by any number of student. Okay, 1 to m, many to 1. So I'm going to combine these two. I told you this higher order thing I have to mention. So many student can enroll any number of courses. Any number of student can enroll any number of courses. Okay, one student can enroll Java. The same Java can enroll by another student also. That student can enroll OS also. Okay, like that I am going to these two entities are getting get mapping. Okay, that's a cardinal, comes under cardinality, right? That's called many to many cardinality. So this is a basic thing. The last one, I have one more thing. One instructor headed by one department. One instructor, I have already one relationship. Now I'm going to include one more relationship. One instructor head of one instructor is head of one department. One instructor is the head of one department. Okay, so this kind of relationship I have. I need to give some small explanation about this exact, especially this one. Actually, this is also one of the important part in this relationship. Okay, what is that? So participation. How the instance are getting participate in this particular relationship. Okay, this comes under the cardinality and degree and all we discussed. Okay, so I have one more participation thing. It's called total or partial. Total or partial. What is a total or partial? Total in the sense every instance participating in this particular relationship, then it is called total. Some of the instance only participating in this particular relationship, then it's called partial. In this example, so every department have some HOD. Every department have some HOD, right? So this is called total participant. So total participant in the sense you have to represent this double line mark. Okay, so every department have some heads. Every department have some heads. Okay, like that. Every instructor need not to be head of the department. Need not like head of the department. Some of the instructor only become the HOD, right? So only only some instance, some some of the values only participating in this relationship. Then it is called partial. So this is partial. You don't need to write these things in this ER diagram. Okay, for your explanation, I am saying this. Okay, some of the instances only participating in this relationship, then it comes under partially participating. Okay, in this every instance participating in this relationship, then it is called total participant. So this also you should know how the total and partial participating relationship comes in your ER diagram. Okay, so partial means some of the instances only participating in the relationship. So it need not to be an all instructors become an HOD of the department, right? But some of the like every department have some HODs, right? So every instance are participating. Some of the instances only participating. Okay, so that's why it's called partial and it is called total. Okay, so hope you understand these concepts of ER diagram from the from problem statement to how we're going to convert, right? So this is very simple example. So so here based on the problem statement I have designed. So if you want you can include some other problem statement also, and you can enhance your ER diagram. Okay, fine. So it's very easy example. So I have omitted this college, right? Because I'm going to create a database for college. That's why I have omitted the college now. So out of which I'm going to include what are the nouns become the entity, what are the properties of the entity become the attribute, right? Attribute and right. So user defined. However you want, you can include. Okay, this is not a constant one. So like that. Relationship. The relationship identification is very important, because based on the relationship identification only we're going to convert that into logical database design, right? So that mapping cardinality is very helpful during that time. If it is one to one, we have certain sort of rules. If it is one to many, there are sort of rules. Many to many, some other sort of rules. Okay, so it's very important how assigning the relationship. That's why you need to study well, right? Like your problem statement, you have to understand thoroughly. Otherwise, you cannot build a proper ER diagram. Okay, fine. So in our next video, we will discuss how we're going to convert this ER diagram to logical database design part. Okay. Thank you.